All right. Well, hi, hello, and welcome to Optimize Cloud Costs with Harness. Now, today's exciting webinar is sponsored by Harness and produced by Actual Tech Media. My name is Jess Steinbach, and I am with Actual Tech. I'm very excited that I get to be your moderator for this webinar today because we are going to get into the strategies, we're going to get into the tactics, we're going to talk about cost savings. And with the help of our wonderful expert presenter here with us from Harness, who I will introduce in just a moment here, we are going to outline some innovative techniques that will allow you to streamline your existing resources, automate intelligently and effectively, and all of this will enable you to reduce costs while maximizing performance, right? That's what we're going for. We want the right arrows going up and the right arrows going down. So down to the cost and up to the performance. We're going to talk about some best practices. We're going to get into some actionable steps. And this is a really cool element too. I like this aspect of the conversation. We're going to talk about how you can actually calculate and evaluate the impact of all of this transformation. So it's not just pie in the sky. We're going to get into some of those actual tangible KPIs and ROIs and all those important acronyms that you need to take back to your team. Like I said, this is going to be a very exciting conversation. We've got a lot to cover. So I'm going to get through just a few housekeeping points and then we'll get this show on the road here. We're going to start out, as always, with a little bit of a guided tour of your audience console. Let's begin in the question section because this is the most important part of our webinar here today. We absolutely want to hear from you as we go through our session. Our expert presenter is going to be watching your questions coming in. I'll be watching your questions coming in. We're going to take some questions on the fly. We're going to adjust the content as we go. So we want this to be a fun and interactive conversation, and that starts with all of you. So make sure you're getting your questions into that questions console. In fact, you can give it a little test run right now if you haven't already done this. Say hi, say hello. Let us know how your day is going. Hey, Robert. Hey, Paul. Hey, George. I saw Evelyn. Hey, Sean, Will, Morteza, and Jim, Andrew. Boy, more than I can even count here. Keep that coming. We want to hear from all of you as we go through our day today. Now, that questions window is also going to be the best place to reach out and let us know if you are having any technical issues. Knock on wood, of course. Hopefully this doesn't come up. But if there's an issue with slides or audio or something dropping out today, the very first thing you're going to try is a browser refresh. I promise a browser refresh. It is the magic spell that fixes most issues. However, if those tech gremlins have really got, now I'm mixing movie metaphors. I can't think of a good Harry Potter. What are the bad little like nits? Anyways, someone write in and tell me what's a little flying creature that causes problems in Harry Potter. I can't think of one right now. But if they're in the system and they're causing problems for you, we want to hear from you. So if that browser refresh doesn't work, message in the questions window, let us know, and our team will be there to help you out. All right, so that's the questions window. Now let's jump over to the handouts tab. The handouts tab is absolutely chock full of resources, cool takeaways, things you are going to want to spend some time with once we wrap up our conversation. So make sure you've got that handouts window open up and spend a little time with that as well. All right, we also have a $250 Amazon gift card that we will be giving away as a prize drawing at the end of our webinar. You do need to be here in live attendance at the webinar in order to win, and all winners must meet the Actual Tech Media prize terms and conditions. If you are not sure what those T's and C's are, that handouts tab that we were just talking about being full of cool information, it's got the full terms and conditions there for you. So click into the handouts tab, scroll down, and you will find them waiting for you there. All right, well, I have a feeling that we're not going to need any extra incentive to get into questions today. I can see a lot of great hand raisers and question askers out there, but just in case, we have this little extra bit of incentive for you. We have a $50 Amazon gift card that we will be giving away to the best question asked. Now, we look at all the questions asked after we wrap up the webinar. So that means even if we don't get to your question during our live Q&A, you are still entered to win. So keep those questions coming in. All right, well, I threw a lot of information at you very quickly. I'm zipping through things because I cannot wait to get into our session, and I'm so excited to introduce you all to our incredible expert here with us today from Harness. That's Abhijit Sharma, Senior Product Manager at Harness. Abhijit, welcome. Thanks for joining us here today.
Thanks a lot for the introduction, Jess. Glad to be here.
Yeah, well, I know you have a lot of really great stuff in store for us, and let's start with that. Abhijit, let us know a little bit about what the audience should be excited to get into today. What are we going to be hearing about from you?
Yeah, definitely. So let's look at the agenda we have for today. So we'll begin by taking a quick overview of the various features we have at Harness Cloud Cost Management. And then we'll focus our attention to a really powerful feature which we call cloud auto stopping, and we'll look at the problem it solves and the various use cases where it can come handy to save us hard dollars. And then we'll deep dive into the various functionalities and configurability that auto stopping offers that makes it easy to use and serve the cloud saving needs for any organization, to be honest. And we'll cover the prereqs for auto stopping, traffic based auto stopping, and various other configuration. And then we'll see all this in action during the demo as well.
Ooh, okay, I'm very excited about the demo. I love getting to see a tool in action. I'm excited about the use cases. I love that we're getting a lot of real world examples in our chat today. So this is all a very exciting roadmap that you've laid out for us, Abhijit. But I'm wondering if maybe before we start running down that path, if we could do a little bit of a foundational info set, and maybe just get an idea. Tell us a little bit more about Harness, and tell us a little bit about what we're here to all talk about today: cloud cost management.
Yeah, definitely. So as we all know, like cloud cost management and optimization is a major problem across organizations, irrespective of their size, right? So Harness CCM is the most comprehensive product in the market that serves literally all the use cases there can be for managing and optimizing your cloud costs. So in terms of visibility, let's just switch over to the next slide. And in terms of visibility, we have perspectives and dashboards that allow you to slice and dice your costs at any granularity, along with a deep Kubernetes visibility into your Kubernetes clusters. We have anomaly detection, budgets, actionable recommendations equipped with alerting and notifications supported for each of these. And in terms of optimizing costs, we offer cluster orchestrator to optimize your cluster spend, commitment orchestrator for intelligently recommending and purchasing the right commitments. And finally, one of our binary differentiator feature in cloud cost space is auto stopping, which will be the primary focus of our discussion today. So now let's begin specifically on auto stopping. What is the problem that it does solve, right? So let's start by addressing that question. So all of us have seen those huge bills from our cloud service providers, right? Which leaves us wondering whether all of these cloud costs are actually being fully utilized. In fact, idle resources are one of the major contributors of cloud bills, right? And compute resources like the AWS EC2 instances, Kubernetes workloads, and databases like AWS RDS, right? These are built every minute they are running, and irrespective of whether or not these are actively being used. So for the time these resources are not serving any traffic, they are just adding to your wasted spend, right? And this wasteful spending increases the operating cost. So pre-production accounts are a major source of these costs, where resources are inactive for the majority of the time, and these are only used when developers are either deploying or testing, right? So this is exactly the problem that Harness cloud cost management addresses with the cloud auto stopping. I'll move over to the next slide. So let's also address why would you need auto stopping in the first place, right? So intelligent cloud auto stopping is a unique feature, like I mentioned, in the Harness CCM space that will essentially reclaim wasted budget without any changes to your infrastructure. So auto stopping can stop idle resources when there is no traffic detected to the resource and automatically start it back again as soon as traffic is received, right? And using auto stopping, customers save up to 70% on their non-prod cloud cost without any overhead of maintenance or running additional scripts to start or stop resources. So for that reason, auto stopping is one of our binary differentiators in the cloud cost space. Yeah, and now let's look at the prerequisites to start using auto stopping. So there's just one prerequisite, which is to set up a cloud connector in Harness, right? So if you want to stop a cloud resource, you set up a cloud connector. If you want to auto stop your Kubernetes workloads, you set up a Kubernetes connector in Harness, and that's largely it. And the process is largely similar across all cloud providers, AWS, GCP, as well as Azure. Specifically for AWS, Harness connects to the customer's AWS account using a cross-account role. So for Harness to be able to auto-stop resources, we need the minimal set of permissions required to be able to detect traffic to the instance and warm up or cool down the resources as and when required, right? And these permissions need to be granted to the cross-account role, like I mentioned. And this all thing is part of the connector setup process, which we'll see in the demo. Perfect. So yeah, within auto stopping now we essentially we have a bunch of features and configuration settings so as to be useful for a wide range of infrastructure requirements, right? So customers environments and use cases can differ significantly, and to ensure that a seamless onboarding happens for all the customers, auto stopping is built with a range of diverse configurability options for serving each of the use cases. So one of this is fixed schedules. So essentially with schedule based auto stopping, what you can do is when you have a resource and you want to shut it down following a certain schedule, you can just configure that within Harness and get started with making hard dollar savings within just a few minutes. The next we have on the list is idle time based auto stopping or traffic detection based auto stopping, right? So although schedule based auto stopping can itself be quite useful, but with companies operating at a global scale, and in order to eliminate any idle time for the resources even outside the scheduled windows, we need something that automatically detects the traffic and essentially switches the instance on or off based on the idle time detection. So this is exactly what auto stopping does for you. If the instance is idle for, let's say, 5 minutes, we shut it down for you and get the instance back up as and when there is any traffic detected to the instance again, right? And just by utilizing this feature, customers have increased their realized savings multifold compared to the standard schedule based auto stopping. Perfect. So this is the high level architecture of what will happen when you onboard your EC2 VMs to auto stopping. Won't go into much of the technical details for the purpose of this webinar, but largely what will happen is, let's say you have an EC2 instance running behind an ALB in your AWS account. When you onboard that to Harness auto stopping, we'll onboard the ALB as well as the EC2 instance, and then we'll detect the traffic flowing through the ALB and manage the EC2 instance depending on the idle time windows that we identify. So that's on a high level what it looks like. Yep, and in terms of supported resources that can be stopped using Harness CCM, so we have AWS EC2, ASGs, RDS, as well as the EKS cluster, along with the ECS service that is the equivalent of Kubernetes. In Azure, we have Azure VMs as well as AKS, which is Azure's Kubernetes equivalent, and GCP we support GCP VMs and the GKE cluster for auto stopping.
Hey Abhijit, I'm here to interrupt you briefly. Can I wedge my way in?
Sure, Jess. Yep, go ahead.
Perfect. We have a bunch of questions coming in, and I know we're going to get into some Q&A at the end, but I also wanted to kind of sprinkle a few at you as we go. So I'm going to throw this one at you because as we're talking about Kubernetes, I think this is a great place to kind of check in on that. So are you ready for a quick question from the audience?
Yep, sure.
Fantastic. All right, Abhijit, here we go. Let's see if we're starting out with a hardball. Which ingress controllers are supported for Kubernetes auto stopping?
Yeah, so we support a bunch of Kubernetes auto stopping controllers. So to name a few, we support Nginx, which is one of the most commonly used one, and then we also support Istio, Traffic, as well as Ambassador.
Okay, that was a very quick and easy answer. You nailed that. A+ on question number 1. There's a lot of questions coming, so I'm going to probably interrupt you again soon, but I'll let you get back to it for now.
Sure, no worries. Yeah, feel free to interrupt me for any questions. Cool. So another major feature that we have in our bucket is the Spot orchestration tool. So CCM auto stopping has full support for Spot orchestration built into it. What this means is you can choose whether you want Harness to provision a Spot node or an on-demand node when warming up the rule, right? So since like you might be aware that Spot instances can be up to 90% cheaper than their on-demand equivalents, this can increase your savings percentage even further. So we will see again this during the demo. Let's see how much time we have, and accordingly you can cover more and more items. Let's go ahead. And yeah, before we jump into the demo, actually, so there's also something called that you can set up in Harness. So let's say when we have an application server and a database server running in our AWS account, a common use case is that the database server will only be utilized whenever there is some incoming request to the application server. So whenever there is no traffic to the application server itself, we can shut down both the instances and save almost twice the cost, right? And this can be achieved by setting dependent auto stopping rules in Harness, and we'll see this in action in the demo.
Abhijit, I'm very excited to get into the demo, and I don't want to do anything to slow down the demo. But we had another question that I'm gonna bring up really quickly before we get into a demo mode, because I think one of the things that we've been seeing come in are these questions around cost savings, and we did get a couple of questions around sort of the hard cost savings. So I'm wondering if maybe I can ask you before we switch into demo mode to answer this one here. How much hard dollar savings can we typically generate using auto stopping? So basically, how effective is this?
Right. So like I mentioned, customers can save upwards of 70% on their cloud bills, right? So the exact numbers will depend on the actual cloud spend. But just to give you some figures, one of our major customers, who are a major technology company, make upwards of $2 million of annualized savings just using cloud auto stopping. So just this feature in the entire package of features that CCM offers, it generates more than $2 million in savings for them.
Boy, and you and I were talking about this in kind of prep for our conversation today, and the metaphor that came into my head was, you're leaving all the lights on in your basement, and you're just leaving those lights on in the basement, and now you have this ability to sort of, press it, and it automatically just turns off without you having to do anything. And imagine the immediate cost savings of just not spending where you don't need to, and what that's going to empower for people and enable for people. $2 million could do a lot when properly allocated. So this is huge, and clearly I think that's a great place to segue into the demo, because now you've got all our buy-in. Show us how it works, Abhijit. Let's get in.
Perfect. Yeah, let me quickly share my screen.
I'll hang out and let you know when I can see. Screen shares are always tricky little tech demons, yep. Aren't they?
Yeah, let me know when you can see it.
All right, I see. Yep, I'm with you. We're in the dashboard with you.
Perfect. Okay. So in the demo, we'll now see how to set up an auto stopping rule and leverage its various functionalities in Harness, right? So for the demo, we'll take the use case of auto stopping an AWS EC2 instance that is running behind an ALB. And this is what so basically if you this is the overview page of the cloud cost management module that we have within Harness. And on the left pane, you can see all the various features, perspectives, cost categories. All this is for cost reporting. And then for cost optimization, we have auto stopping rules like we were discussing. We have a bunch of different types of recommendations. We have commitment orchestrator to automate the purchase of commitments for you, and cluster orchestrator to essentially have an intelligent autoscaler for your clusters that can contribute significantly to your cluster cost savings. So that's what you can see on the left. And then we have, of course, the governance features, the budgets, asset governance, and anomalies. But we'll focus our attention specifically to auto stopping rules for today's discussion. So let's start with the prerequisite that we discussed. The first thing is we want to set up a connector to connect to the AWS account which has the EC2 instance that we want to auto stop. So we'll head over to account settings, and under account level resources, we'll open connectors. And this page will essentially list down all the connectors that you have created in Harness, right? So we can see this. I'll just quickly. So essentially, in this, from this button on the top left, you can create any new connector. You'll click that button, and then this under the cloud cost section, you can create AWS, Azure, GCP, or a Kubernetes connector. So when you click on AWS, this overlay window will open wherein you can configure the different settings. So for the purpose of this demo, I'll just open an existing connector, which is this one, and edit the details on that. So this is what the flow will look like. So you'll enter a connector name, you'll specify the account ID, which this is essentially the AWS account ID, which has the instance that needs to be auto stopped. And then we'll continue, and then we'll select the different features that we want to enable in this particular AWS account. So cost visibility is one of them, which we have already enabled. So it's checked by default. and then we have inventory management. Cost visibility essentially is uh, granting access to your curve so that we ingest the data, and then you can view the entire cost reporting features will become accessible once you enable this. And similarly, we have inventory management, order stopping, governance, and commitment. So you can choose the features that you want to enable. In our case, it is optimization by auto stopping. We'll choose that and continue to the next step. This is the step where you grant the permissions uh, to the cross account role that we use to connect to the AWS account, right? So when you click on this launch template on the AWS console, this will open a CloudFormation template in your AWS account, which you can simply execute. And at the end of that CloudFormation template, the result of that will be a cross account role ARN and an external ID, which you can then simply enter here. This allows Harness to connect to your account using this cross account role and external ID. And when you save and continue here, we see verification is successful. There are no errors in the validation. This means that we have granted all the required permissions to the role, and auto stopping will function perfectly. So let's finish this setup and head over to the auto stopping dashboard. Okay. Okay. So before we create a rule, what I've done is I have created a bunch of resources in AWS, which essentially is similar to a typical setup that customers have in their non-prod environments. We'll just quickly look over that common environment setup, and then we'll see how we'll onboard all those resources that we have in AWS to Harness auto stopping. Cool. So what we have here is this is the AWS account, the connector to which we have seen in the last few minutes. So we see there are like a bunch of resources in here. These are EC2 instances. One of these is demo EC2 depth service, and the other one is demo EC2 next-gen CE service. So these are two instances which are both of them are running. I'll just refresh to confirm. Yeah, so both of the instances are running. And what we have inside these EC2 instances is an Nginx server running in both of these. This is just for the purpose of demo. Inside that, you'll have your own service running in a typical use case. But for the purpose of this demo, we do have the Nginx server running, so that when we hit the URL, when we get HTTP traffic to the instance, we get a response that we can use to confirm that the instance is up, right? So these are the two instances, and both of these instances are behind a load balancer. So when we head to the load balancer section, I'll refresh the page. Yeah, so here you can see, right? So there are two load balancers, demo ALB next-gen CE and demo ALB depth service. So each of the two EC2 instances that we just saw is running behind one of these ALBs, right? And there are corresponding target groups that the instances are mapped to, right? So if you open one of those ALBs, you'll see a DNS name, right? This is the setup that customers will typically have. We'll have a DNS name for the ALB, and this is mapped. Essentially, you'll also have an internal DNS, something like Harness IO or something like that, and you'll map that to the DNS name of the ALB. So that configuration has been done in Route 53 that you can check here. So we have a couple of CNAME records, and both the ALB domains are mapped here to the Harness domain, which is demo depth service.lightwingtest.com and demo nextgence.lightwingtest.com. So when we hit these URLs, this will redirect us to the ALB domain, and then ALB will then route the traffic to the instance, which essentially has the Nginx server running. So let's quickly hit that one of these URLs and confirm. So we have demo depth service.lightwingtest. Let's refresh this. Okay, looks like it's still loading.
You gotta love in live events, right?
Yeah, this worked. So demo nextgence.liveblingtest.com. When we hit this, we get the welcome to Nginx page. Since, like I told you, the Nginx server is running in both of the instances, right? So this is just to confirm that instances are up, and we get a response from the Nginx server. Perfect. So that's like a typical setup that customers have, and then now we can go ahead and create an auto stopping rule for both of these instances. Yeah, so this is the auto stopping dashboard. Here you'll get a summary of all the auto stopping rules that you have created for any auto stoppable resource that you have across all the cloud providers. So this is like we have a couple of them, a couple of Kubernetes auto stopping rules in here. If you check another account, there will be like Azure, AWS. So these are all our internal test accounts. So we keep creating and deleting rules in here. But yeah, this is the summary page, and here you'll get a list of all the auto stopping rules that you have, and you'll see a spend and savings summary as well. So you'll see on every day how much dollars did you save using all the auto stopping rules, and that you can see per auto stopping rule as well. And like you have a high level summary of each rule listed here as well, right? Okay, so let's start with creating a new auto stopping rule. So the first step is to select the cloud provider, which is AWS for the demo purposes. And then inside here, you get the list of all the connectors, all the AWS connectors that you have hooked inside Harness. So the connector that we are interested is this one. We'll select that and hit the next button. So here you configure a bunch of items on this page. So one thing is the auto stopping rule name. So we'll start by configuring the dep service. So let's say demo dep service, and we have the idle time. So idle time is the time after which the rule should stop the resources. So if you set it to 5, essentially what will happen is whenever there has been no activity and no traffic into the instance for the last 5 minutes, Harness auto stopping will automatically stop the instance and shut it down. So that can be configured from here. The minimum you can do is 5 minutes. And then if we head to step 2, this includes the resource that needs to be managed by auto stopping rules. So our resource that we want to auto stop is EC2 VM. So we'll select that, add an instance. This lists all the instances in that account. So we'll just search for our instance, which is this one, demo EC2 dep service. We'll select this one. So for our use case, we are selecting just one instance in here. But if there are like a bunch of instances that you want to auto stop that are running behind the same ALB, you can just select all of those in here, and auto stopping will just work out of the box. Yeah, so we selected that, and then this is the spot orchestration that I mentioned during the presentation. So here you can either choose the fulfillment option to be either spot or on demand. If you choose that to be spot, we'll try to look for a spot instance if it is available whenever we warm up, whenever we spin off another instance. And if it is available, we go ahead with spot. If it is not, we have the flexibility to fall back on an on-demand instance in case spot is not available. And in fact, like you might be aware, there is like a 2-minute interruption notice that AWS provides before it takes the instance away from you. So if we get that interruption notice, we process that and we automatically provision another instance so as to ensure availability. So for the purpose of this demo, we'll choose on demand. Then in the advanced configuration section, there are a bunch of options. One is the dependency, which I briefly spoke about during the presentation. So here is where you configure, let's say if you have an application server and a database server. So you'll add a dependency and select like one of the other rules, which will be, let's say for the database server. So you can set that as a dependency in here. We'll see that in action in a few minutes. We'll just set up this particular rule, and then we'll create another rule for the other instance that we have, and then we'll set up the dependency and see this in action live. We also have fixed schedules that you can configure here. This is essentially just setting up the schedule. So let's say you want to turn off your instance on weekends or post work hours. That can be simply configured from here. Add fixed schedule, and then you set up uptime or a downtime. So downtime is essentially you want the instance to be down in that scheduled period, or you can also configure uptime. So let's say you don't want your instance to be turned off at any cost while a certain time period is active, right? So you can set those uptimes as well, and the rest of the time instance can be down. So all this you can configure from here. We'll just configure it for the other instance that we have. For this one, we'll set up an idle time based auto stopping, which the idle time we have already configured as 5 minutes in here. Cool. Anything else we are missing? Yeah, so there's another configuration that is called the dry run that you might be able to see in here, right? So what this allows you to do is essentially just evaluate how much savings you can potentially make by getting this rule up and running. So what this will, if you enable dry run flag, Harness will not take any actions for stopping the resources. It will just keep monitoring the traffic and idle times, and it will keep also monitoring the potential savings that can be made had the rule been active, right? So it won't take any actions, but you can just compute potential savings if we just enable that. For the demo, we actually want to take the action and stop the instance, so we'll we'll not select the item. Yep. We'll hit next, and this is where we configure the access setup. So whether your traffic to the instance is SSH or RDP, that can be configured in here, or if it is HTTP or HTTPS, all those things can be configured in here. For our case, for the purpose of this demo, we'll use HTTP traffic into the machines. So that can be configured from here. And in this next step, we choose the application load balancer, which behind which our instance is running, right? So if we just click on the drop down, it will list all the ALBs in our account, right? And for the dep service, this is the ALB. This opens this overlay, which you can configure. So that the domain that we'll use is harness.lightwing test. You can configure any of your internal organization domain in here. We'll do harness.lightwingtest.com, and that's it. In the next step, you can configure the region, VPC, and security groups. So all these are prefetched from the account and are auto-filled. So most likely you won't need to change them. And then we can save the load balancer. It'll take a few seconds. What this will do is it will create a load balancer entity, an access point entity on the Harness side, which essentially will allow Harness to monitor the traffic through this ALB. Yeah, that's done. So now that the ALB is onboarded, we can select, we can essentially specify all the port configuration in here for the application load balancer, right? So all the port configuration that you configure as ALB rules needs to go in here. For our case, we'll just focus on HTTP traffic. So I'll remove the other one, the 443, which is HTTPS. Health check looks good. And here we need to specify the URL that we essentially use to access the resources, right? So either you can use an auto-generated URL that we generate for you, or if there is, most likely what happens is there's already a URL that engineers or internal teams use to access the resource. We'll configure that here. In our case, this is the same as what we configured in Route 53. So we'll just open that. Demo dep service, lightwingtest.com. And we'll paste that in here. So yep, that's the URL that will be used to access the resources. Then the last section we have here is the custom exclusion and inclusion section. So what happens in many cases is whenever you have an instance up and running, you will have your services running inside the instance, and you'll have user traffic hitting the instance and the service inside it. But other than that, that's the most important use case. Other than that, there are also some other jobs that you might have running in other places that keep hitting this particular instance just to make sure, for telemetry purposes or for health check purposes, that you would typically not want to contribute to the traffic. So if you have an instance running and there has not been any user traffic in the last 5-minute window, but there have been several hits by these health check jobs and so on. So you typically won't want these health check jobs to contribute to keep the instance running. So this is what you can configure in here. So you can custom exclusions and add path based or IP based matches for that. What this will do is whenever there is uh, traffic incoming from that particular IP address, it won't be considered as traffic, and whenever that 5 minute or 15-minute window, whatever we have configured in the rule, that passes and there is no actual user traffic, then the instance will be shut down. So that can be configured from here. We hit next, and this is where we review all the information that we entered in the previous steps. All looks good, and we save the rule in here. Okay, so this is configuring the rule. Looks good. The instance is running as rightly detected. We'll try hitting the custom domain that we configured in the rule just to see if the instance is up. Yep. So I reloaded this page, reload again. And now you see this page, which is generated by Harness. This is a custom loading page, which you'll see whenever you onboard an instance to Harness. So whenever the instance is stopped, it's in a stopped state, and you hit the URL, Harness will show you this loading page, and then it will automatically go away whenever the instance is up and you have your services ready. And here, when I refresh the rule, you can also see this log section. You can monitor all the logs, whatever actions Harness is taking for auto stopping or auto starting the resource, and whatever network traffic activity that happens through the ALB, which contributes to idle time, that is logged here. And any errors during auto stopping, auto starting, let's say you missed giving all the required permissions, all those errors will be listed in here whenever there is any issue. So this log section contributes to that. Perfect. Yeah, so this page came back up. Awesome. So what we'll do is we'll wait for so this was configured at 11:06 p.m. IST, and we have a 5-minute idle time window. So while after these 5 minutes, the auto stopping rule will shut down the instance when there is no network traffic, right? So while these 5 minutes pass, we'll create another auto stopping rule using a schedule, which we saw for the other next gen CE service that we have. So we'll click on new auto stopping rule. AWS connector is still the same since it's the same account. We'll hit next. Demo next gen CE. Idle time, let's keep it as it is. EC2 VMs. Next gen CE, we select this instance. So all this is same as what we saw already. On demand is the fulfillment. And here we can configure the fixed schedule. So let's add that fixed schedule for downtime. Starting today, which is 27th of August. And what it will do is for every day, for the entire day, it will keep the instance down. This is just for the sake of the demo, but you can configure something like on weekends, keep it down, or post working hours, keep it down. So this is like a brief explanation of whatever downtime you have configured. So resources will be down every day for the entire day starting from today. Perfect. Let's hit next. HTTP and TCP configuration we don't want to configure for this one, since this is just a schedule based rule. We don't need to involve ALB for this. We'll just skip that for now. We'll review the items. Looks good, and save the rule. So in a few seconds, Harness, since we have a fixed schedule configured for downtime for this particular rule, auto stopping will take that into consideration and stop the instance which is currently running. So we can also check the AWS portal to confirm that this instance is actually stopped, actually running right now. So this is EC2. Oh, this is the dep service. This is running, and then next-gen CE is this instance stopping, right? So it was running earlier, and if I head over here and refresh, you'll see this cooling down state on the right, right? So rule status is cooling down, triggered from optimization. You can see that in the logs, right? Starting the downtime schedule. Since we have downtime schedule for the entire day, this particular instance has been stopped by the auto stopping rule, right? Yeah, so this is how it works in action. We'll just confirm, we'll reload in AWS and see that the resource state is now stopped. Okay, now let's look at the other rule that we had created. So while we are waiting for it to go down, Jess, let me know if there are any questions. We can take maybe one question now and move up.
I love that plan. Let's do a quick little question break, and then we'll come back to our cooling. This is like cooking, right? You got to let everything cool and settle. All right, let's go with this one here. Actually, I'm gonna combine a couple of questions because I got one. Evelyn and I were just chatting about this. She had some questions about the reporting that's available on the cost savings, and there were a couple other questions that came in around how they're actually getting that data, how the cost savings are actually calculated. So I'm wondering if you could maybe give us a little bit more insight into how those savings are calculated and then shared with folks in the audience here.
Sure, definitely. So since we considered this EC2 auto stopping example, I'll just take that as an example. So essentially, how we compute savings is we compute the exact time intervals during the day when auto stopping took action to shut down the instance, and whenever Harness cool down an instance based on idle time or based on a schedule, and then we identify the last known hourly resource rate for that instance based on the cost and usage report that you have, right? And using these two numbers, we generate the savings or the potential savings when you're using it in a dry run mode, right? So the savings numbers are computing using costs from the actual AWS cost and usage report. So the savings that we show here on the dashboard that you see are actual savings that will totally be in line with your actual AWS bills, taking into account all the discounts, coverages, and amortization on your cloud usage.
Perfect. Well, that was nice and easy. Do you have time for another question, or do we need to get back into our demo?
Let's see. Yeah, maybe we can take one more.
This is where we're like tasting the soup to see if it's ready. Okay, so I'm going to try this question here. We had a question come in around the kind of support. So for somebody who's looking at their environment and thinking this is going to be really hard for us to know what rules we should be applying. So is there support from Harness in terms of which automations and kind of training and how to deploy and coaching that might help a team know what they need to put into place, as well as then actually putting these things into place?
So this is about the documentation, is it? We need the documentation for setting up the rules.
Well, I think Joseph was actually looking if there's a way to sort of automatically scan the network and tell them what they need. But yes, any sort of coaching or support that would be offered from Harness in terms of what automations to put in place across their cloud services.
Got it. So we do have custom built dashboards wherein we surface all the EC2, basically all the auto stoppable resources which I covered during the presentation, right? So AWS, it is EC2, GRDS, and GCP VMs, Kubernetes clusters, and so on. So under the dashboard, you will have a list of all the auto stoppable resources that you can then go ahead and create an auto stopping rule for. And also this quarter, we are working for making it much more easier for the user. So what is already in the plan, and we have started building it, is what you call a smart advisor. So that will enable you to bulk create auto stopping rules for all of these resources that we list in the dashboard today.
Perfect. All right. Well, let's should we get back into the demo and then we'll stop again for some more questions?
Yep, absolutely. So yeah, this was the dependency, the dep service that we had created, and we had set up 5 minutes of idle time, and it after 5 minutes it has detected that it should cool down the resource since there has been no traffic to the instance so far in the last few minutes window. So this cooldown was triggered from optimization, and now we can see that rule status is now stopped. We can just confirm that, go to the dependency service, EC2 instance, refresh here. Right, earlier it was running, and now you can see the instance is now stopped. So the last thing that we will see as part of the demo is setting up the dependency, which is why we created the two rules for the instances that we have. So we'll head over here. So now you see both of the rules are in stop state that you can see from this overview page. What we'll do is we'll configure this demo nextgen CE rule. And we'll set up the dep service as a dependency for this rule. So we have a fixed schedule right now. What we'll do is we'll remove this downtime fixed schedule, and then we'll add a dependency to the other rule. So like I mentioned, the dependencies can be configured in here. So we add a dependency on the dep service, so demo dep service. This rule we have already created, and we configure a delay of 5 seconds, which essentially means after the demo dep service is already up, wait for 5 more seconds before you warm up the nextgen CE service, right? Because this is like a common use case that we have seen that sometimes after booting the instance, you need some sort of a warm up window within for the service that is running inside the instance, right? So that delay can be configured in here. So you set up that dependency, and in the fixed schedule, we'll set up an uptime. So right now, both of the instances have been stopped. When we configure uptime for demo nextgen CE, it will automatically bring up the other instance since we have set that as a dependency in here. So yeah, it should be effective from 27th of August, starting today, every day, all day, uptime, apply. So we have a fixed schedule and we have set up a dependency. So hit next, skip the HTTP configuration for now and save the rule. So right now, both of the instances are in stopped state. We configured dependency and an uptime schedule. Now let's see. So what will happen is we configured only in nextgen CE, but let's look at the logs for this dependency service. We confirm that the instances are stopped. This now moved to pending. So if you see, we'll go to the dependency service, and this particular instance is now warming up because this is a dependency for the other rule which has an uptime schedule. So for that to be up, we need to warm up this resource as well. So in the logs, you can clearly see this is triggered from a dependency warm up. And once this is up, it will start warming up the actual other instance as well. Yeah. So the dependency is now up and running. We'll confirm this from AWS also. Instance state is running. We can hit the URL. This will say welcome again. So yep, the instance is up. And now let's look at the original service, which is demo nextgen CE. In the logs, it says warming up dependencies. So after this is fully completed, it will start warming up this particular instance as well. Yeah. So on the right, you can see the rule status is now warming up, triggered from schedule warm up because of an uptime schedule. So the instance is now up and running, and both our Nginx servers will also be up and running because of that. You just hit it and see that it works. So yep, that was all that we had for the demo today. Let me know if there are any questions or concerns. We can take them now. I'll stop sharing.
Yeah. We've got lots more questions, and we are maybe got about 5 minutes left, so I'm going to zip through a few of them before we have to let you go. But Abhijit, that was such a great demo, and really interesting to see things live and in action, and really watching that happen in real time is pretty cool. So I want to thank you for walking us through that. You ready to dive into a few more questions?
Yeah, sure. Shoot at it.
Let's do this. Okay. Got a question here. We did get a couple of questions about various different platforms, so I'm going to start with this one here. Do we support auto stopping? Okay, yes. We have an organization wondering if Harness would support them auto stopping with AWS GovCloud accounts.
I see. Yeah. So auto stopping is fully supported for AWS GovCloud accounts. So during the connector setup, you must have seen that checkbox. So you can simply check that box if your AWS account is a GovCloud account, and rest everything remains the same.
Okay, quick and easy. I like it. All right, we're gonna get through a bunch of these questions. You keep being so efficient. Okay, does Harness CCM also manage node auto scaling for Kubernetes clusters, which would enable us to save some costs?
Yeah, absolutely. In fact, this is like a recent feature that we have launched. This is separate from auto stopping though. It's called Cluster Orchestrator. With this, Harness fully supports workload-driven intelligent auto scaling for your Kubernetes cluster. So I briefly mentioned about this, but didn't touch upon that in detail since we were focusing on auto stopping. So this Cluster Orchestrator also comes with the spot orchestration capability and even more capabilities added to it, so that your clusters can reliably run using spot instances while also maintaining an availability guarantee with the on-demand nodes. So that's fully supported, but that's just a different feature. Maybe we can cover that in the next in one of the next sessions.
We'll just have to keep bringing you back, Abhijit. We've clearly got more to cover, but we're not done yet. We've got time for a few more questions here. Is it possible to manage auto stopping via Terraform?
Yes. So we have our own Terraform resource. So Terraform is like fully supported for creating and managing auto stopping rules in Harness. In fact, maybe let me share a link to the documentation in the chat. So let's see if we have it.
I think I've got it. Let me post. You and I were looking at this earlier. Let me just post that now, and I'll share with everyone out there. There we go.
Yeah.
So you should all have that in the questions window. If you look now, that's your link to learn a little bit more about that. Sorry, Abhijit, keep going.
Yeah. So this link will have like the in-depth details on how you can use Terraform to set up auto stopping rules in Harness and continue to manage it while you're using it. Yep.
Perfect. Okay, nice and easy. We've got all kinds of great resources. Okay, I am going to have to start to wrap us up, but before we close things out, there's a couple things I want to say. One, Abhijit, we are nowhere close to getting through all of the questions that we got today. You got a lot of questions in from the audience, and I know there's a lot more to cover here. Like I said, we could probably do 3 or 4 webinars with you, and I hope that we will do all of them in the near future. But I do want to let you know that we're going to take all of the questions that have been asked today, and we're going to get them to Abhijit and to the Harness team. So you will get answers back from Harness. So keep those questions coming in. Make sure that you get those questions in if they're still rattling around in your brains. And if you ask something that we didn't get to today, stay tuned because you'll be hearing back from Harness. Before you leave us though, Abhijit, if somebody is looking to learn a little bit more right away, they have those burning questions and they just can't wait for you to email them back, what would you recommend as the first step to getting started, to kind of taking action after they leave the webinar here today?
Yeah, definitely. So you can either reach out to our website, which is www.harness.io, or you can just go ahead, if you think you're equipped enough, you can just go ahead and create an account on app.harness.io. It's fairly straightforward, and you can just start setting up your connector like I showed, and just go ahead.
Perfect. So just jump in, just do it. And I do want to say, Abhijit, we've got some shout outs coming in. Paul is really excited about the link that we just sent. Will wanted to say thank you. Will has the coolest name, literally, Will Cool. Amazing. I hope that's your real name. That's amazing. We are getting a few more questions in still. That's great, Warren. Thank you for getting that question in. As I said, we're going to make sure that that gets answered via email. Shoot, you know what? I'm just going to ask this really quick, Abhijit, because it's a good question to end on. Warren was wondering about small teams versus big teams. Is this a solution? Is Harness going to work for any size organization?
Absolutely, yep. So all the features that we have within Cloud Cost Management are designed to work both for small teams as well as large organizations, right? And specifically for auto stopping, right? If you see, you will have idle resources no matter what, no matter if you are a small company or you're like a really big organization. And if that keeps on running and that keeps on draining your cost, you can't use that cost in your other business operations. That's going to be really useful, and definitely it's definitely usable for both small as well as large organizations.
Isn't that funny? You know, I think sometimes, yeah, the biggest impact could even possibly be to smaller teams, you know, where you need that cost saving the most, and you don't always have that team of people that can cycle around and keep an eye on this. I just got another request to repost, because I know sometimes it doesn't always re-rack the chat here. So I'm just reposting that link for all of you guys again, because folks are wanting to read that. You can also visit the handouts tab. So in the handouts tab, we have a link over to the Harness website. There's some great resources and ways to kind of follow up. You can, you know, book that more personalized demo. You spend a little time chatting with the team and learn a little bit more there. So make sure you've got that Harness website opened and ready to explore. Abhijit, I wish I could keep you a little bit longer, but I've already, this is called a Minnesota goodbye. It's when I say goodbye and then I just one more question. So I'm going to stop Minnesota goodbye you now, but I hope that we'll get to chat with you again, and thank you so much for being here with us today.
Awesome. Thanks a lot, Jess, for having me, and let's see, we have a lot of questions. Get them through and we'll get all of them answered.
You bet. I'm getting them right over to you, my friend. Thank you. All right. And to everyone that's asking those questions, keep that coming in. As Abhijit just said, the Harness team is so psyched to go through these later and spend a little time answering all of you. So please do make sure you're getting those questions in before you head out today. Make sure you've got the handouts. Make sure you've opened up the Harness website and you've got that link in the chat now. So make sure you've got that as well. Some really great follow-ups to our conversation. Before we bring things to a final close, I do want to make sure that we give away our $250 Amazon gift card to our lucky winner who is live and present here at the webinar and meets all of those webinar T's and C's that we were talking about also in the handouts tab. Now, really quickly, I do want to remind you that the $50 best question gift card we review after we wrap. We're going to look at all these wonderful questions that have been coming in and we're going to send that out. So stay tuned for that one. But our $250 Amazon gift card today is going to Brock Lawns from Utah. Brock Lawns, or Lonis possibly, from Utah. Congratulations to you, Brock. As always, we will be in touch about claiming your prize after we wrap. Well, with that, on behalf of the Actual Tech team, I want to once again thank Harness for making this webinar possible, especially to Abhijit for such an interesting conversation, such a cool demo, really helping us explore some of those practical and insightful cloud cost optimization strategies and getting into this auto stopping conversation. You know, I'm hoping that today you were feeling like you got to explore some actual tangible ideas for how you could transform cloud resource management and reduce those costs without leveling down on efficiency, right? You know, because that's the thing. It's easy to just start hacking things out. Well, maybe not easy, but I think that's often what happens is things just start getting cut and reducing and reducing and reducing, and then you can't actually function, and you certainly can't meet those big, exciting goals that you have as an organization. So this is a way that you're able to reduce purely through efficiency, you know, automation and cutting out unnecessary waste. And I think that's an amazing place to start. Hopefully that kind of has everybody's brains lit up and tickling. I saw a few people asking, hey, I have to bring this to my CEO or my CISO. So I'm hoping that you've all gotten those really key ideas that you can bring forward to your team. Again, if you haven't or you need more, you know, you're not feeling that argument is fully formed, get onto that Harness website and spend some time there and reach out to the Harness team and let them get you the information that you need in order to take that conversation forward in your organization. I'm really, I have to say, enjoying the conversation with all of you today. I'm loving the, oh, hey, Brock. Yeah, I see you. Congrats. I see our prize winner in the chat there. So I'm hoping that that you will all carry these conversations forward in your organization. I hope that you're feeling like you've gotten some truly practical and actionable steps that you can bring forward. Well, I want to thank all of you for coming and joining in and being a part of this conversation with us here today. I've had an absolute blast. I know I've learned a ton, and I hope that you're feeling that as well. I cannot wait to see you all at a webinar again soon. And until then, I hope you have an absolutely beautiful end to your day. Thanks all.